Hello, everyone, and thank you very much for joining me on this session. My name is Spencer Allingham. I'm the Technical Director at Condusiv Technologies for Europe, Middle East, and Africa. And yeah, I'm looking forward to taking you through just how you can get more workload processed from databases that you're running like SQL Server or MySQL or Oracle. Basically using the hardware infrastructure and the setup that you already own, just simply by installing a little lightweight software utility. So just a point of housekeeping, as we're going through, if you have any questions at all, please feel free to put them in that Q&A box, and I'll have a Q&A session at the end if we get any questions as we're going through, and I'll do my very best to answer them. Okay, so now, whether you're running SQL in a physical or virtualized environment, most SQL DBAs would welcome faster storage at a reasonable price. Condusiv's V-locity software is designed to provide exactly that, but using the storage hardware that you already own. And it doesn't matter if you have direct attached disks, if you're running a tiered SAN, have a tray of SSD storage, or if you're fortunate enough to have an all-flash array. That storage layer can be a limiting factor to your SQL database's productivity. The V-locity software reduces the amount of storage I/O traffic that has to go out and be processed by the disk storage layer, and it streamlines or optimizes the data which does still have to go out to disk. And the net result is that SQL can typically get more transactions completed in the same amount of time, quite simply because on average it's not having to wait so much on the storage layer before being able to get on with its next transaction. And V-locity can be downloaded and installed without any disruption to live SQL servers. No SQL code changes are required and no reboots. You just simply install, and typically you'll start seeing results in just a few minutes. Now, before we take a more in-depth look at that, I'd like to briefly mention that last year, the V-locity software was awarded the Microsoft SQL Server I/O Reliability Certification, which is quite a mouthful for me. But this basically means that whilst providing faster storage access, V-locity didn't adversely affect the required and recommended behaviors that an I/O subsystem must provide for SQL, as defined by Microsoft themselves. And Microsoft ran tests for this in Azure with SQL 2016, and they used HammerDB to generate an online transaction processing type workload. And not only was V-locity able to jump through all of the hoops necessary to achieve the certification, but it was also able to show an increase of about 30% more SQL transactions processed in the same amount of time. In this test, that meant roughly 30% more customer orders processed. And they probably could have processed more too if they'd allowed V-locity a slightly larger RAM cache size. Now, most SQL DBAs are familiar with why split pages are bad for performance. You know, if you've got room and your update or insert doesn't require a split, well, this is pretty fast because SQL is just updating one page and then writing it out to disk and, of course, to the transaction log. But if the updated or inserted row doesn't fit, SQL needs to allocate a new page, move about half of the rows to the new page, and then write both pages out to disk and to the transaction log. And in addition, the pages in all the indexes that point to the data pages, well, they need to be updated too. So let's say that your table had one clustered index and 4 non-clustered indexes. That would mean at least 7 pages would need to be updated. You'd have 1 for the clustered index structure, 4 for the non-clustered indexes, and 2 in the data pages in the clustered index. So this page split would result in a minimum of 7 times the I/O as an insert or update that didn't require a page split. And each I/O that takes place takes a measurable amount of time and resource to process. And the same is true when the Windows file system splits data as it writes out to the logical NTFS volume. And that can have significant performance ramifications too. And this is basically why DBAs format volumes to be used by SQL with a 64K cluster size rather than the NTFS default of just 4K. It basically helps to avoid split I/O situations when writing to disk and keeps the performance-losing file fragmentation from building up quite so quickly. But it doesn't completely fix the problem. Oh, I'm sorry, I just saw that somebody's having trouble with the audio. Can anybody else hear me? Can we just have somebody put something in the chat box to say that you can hear me okay? Hopefully it's just one person. Ah, great, okay. All right, so for those of you that can't hear me, I know you're not going to be able to hear this, but maybe somebody can put something in the chat box for me while I'm presenting. This session is being recorded, and the recording will be made available to everybody after the session. So if anybody is having trouble with the audio, please don't worry, you will be able to review this. Okay, so as your NTFS file systems mature over time and files get created, extended, and deleted, what happens is the free space on the NTFS volume will become more and more fragmented into smaller and smaller free space extents, increasing basically those split I/O situations when you're writing out data. And each time your write is split in this way, the data is being sent out to the disk storage layer in a separate I/O packet. And like split pages in SQL, each I/O takes a measurable amount of time and resource to process. So in the real world, a gigabyte of storage I/O traffic that should be written in maybe 2,000 or 3,000 I/Os could now be taking 30,000 or 40,000 I/Os to complete. And we call the performance penalty that these split I/O situations cause the Windows I/O tax, as in a tax on your performance due to the split I/Os. Now, excuse me just one moment. Oh, my apologies. In a virtualized environment, this performance penalty can be amplified by something called the I/O blender effect. And what's happening here is that you have small fractured I/O packets coming from the virtual machines, and as they pass through the hypervisor mixes these I/O streams together, causing a randomization effect. So then what you get coming out between that physical host hypervisor and the disk storage controller is now a chaotic mess of small, fractured, and now very randomized I/O streams. But by the time they hit that storage controller, they couldn't be less storage friendly. It basically means that the storage controller is only receiving data in very small packets at a time. So it now only has the opportunity to create very small stripes across its media, and that means many more storage level operations than if the data hadn't been split as it was being written all the way up at that NTFS layer. There we go. So the V-locity software helps Windows avoid or prevent most of the excess, unnecessary, performance-losing split I/O traffic, and it replaces that with far fewer storage I/O packets, each one carrying a larger payload of data. And this makes the movement of that data between server and storage more efficient, much like avoiding page splits in SQL wherever possible. And it allows the disk storage to store the data using far fewer storage level operations. V-locity will also help create those nice large free space extents quietly and automatically in the background using only otherwise idle compute resources to make it easier basically for the Windows write driver to write into. So think for a moment of a busy motorway at rush hour. Imagine that you have lots of cars sitting bumper to bumper with one person in each car, and really none of them are getting anywhere very quickly. You should imagine the look on their faces. Now, imagine that each car on the motorway is a storage I/O packet, and that each person in each car is your data. What the Velocity software is basically doing is taking all of the people out of the cars and placing them in buses or coaches, and removing all of those cars from the motorway and getting rid of all of that congestion, so that now all the people or your data can now flow to their destination in a much more efficient manner. I hope that makes sense as an analogy. But that's only half of the story. Velocity also introduces a RAM caching technique into the Windows operating system that further reduces the read I/O traffic that the back-end storage has to deal with. And the performance benefits provided are in addition to SQL's own buffering and any caching natively provided by the Windows OS. And this is basically how we could get 30% more SQL transactions done in the same amount of time during that Microsoft I/O reliability testing that I mentioned before. Quite simply, SQL could get more work done in the same amount of time because it wasn't having to wait so much on the disk storage layer before being able to get on with its next transaction. And basically because server-side RAM is faster than disk storage. Even if you have a tray of SSDs or an all-flash array, RAM is still faster. Oh, and it absolutely works with both physical and virtualized SQL servers, and in the cloud as well. So storage I/O reduction, optimization, and RAM caching represent a significant reduction in workload that has to be processed by the back-end storage. And this is not only true of SQL Server's storage traffic, but other workload types too. So in this example on the screen, let's say that the first VM is hosting SQL, and the second is hosting the application that interfaces with SQL, and the other two VMs are hosting busy file servers, and they're all sharing the same back-end storage. Now, you might have a situation where the traffic from the file servers are taxing the performance of SQL just simply by keeping the storage layer busy. So SQL isn't necessarily the cause of the disk storage being slow, but it would likely be affected by the increased disk I/O queue depths and latency caused by the busy workloads on those file servers. So my recommendation would be to install the Velocity software on all Windows machines, as many as you can install it on, sharing that same back-end storage. And that way, from the point of view of the storage, it's now doing the least amount of work, regardless of which VM is generating the most workload at any given time. So at this point, some of you will be thinking, yes, but SQL is already using most of the available memory in the machine. How can you possibly create a RAM cache? And it's true. If SQL is left uncapped, there typically wouldn't be enough RAM for Condusiv software to create a cache with. We've intentionally designed our software so that it can't compete for system resources with anything else that's running, so that we really can never be the cause of a memory starvation situation. It would only use some of the free RAM that isn't being used by anything else, and it will dynamically size the cache, handing RAM back to Windows if other processes or applications need it. So for best results, you can easily cap the amount of RAM that SQL takes for its own form of caching or buffering. On busy database servers, if you can leave 16 gigabytes of RAM free, you'd have a Velocity cache size that would really be enough to make that machine's performance fly in most cases. And if you can't spare 16 gig, leave 8 gig. If you can't afford 8 gig, leave 4 gig free. Even that is enough to make a difference. If you go much smaller than that, though, then the cache size would really be too small, and any performance improvements would be a little bit limited. So you might also be thinking that SQL's buffering is good enough. So how does Velocity's caching complement this? And At a basic level, SQL's cache does do a pretty good job, and whilst that does have a positive impact on performance, V-locity's RAM caching is designed to eliminate the type of storage I/O traffic that tends to slow the storage down the most. And whilst that tends to be the smaller, more random read I/O traffic, it's not always the case. So V-locity uses a very lightweight storage filter driver to gather telemetry. And this allows the software to learn useful things like, what is the main application in use on this machine? What type of files are being accessed? And what type of storage I/O streams are being generated? And at what times of the day, the week, the month, the quarter? So it can be very intelligent about what the hot blocks of data are that need to be in the RAM cache, and more importantly, when. And it can also use that telemetry data to figure out how best to size the storage I/O packets to give those main applications running the best performance. And then, of course, if the way you use that machine changes over time, V-locity can automatically adapt to those changes without you having to reconfigure or tweak any settings. It's completely automatic. Validating results is super easy. First of all, you could measure the amount of SQL transactions being done each day to see if they increase. Some customers see reports that they generate take less time to produce, or SQL imports take less time, batch jobs complete more quickly, that sort of thing. Some customers have even done a simple stopwatch test to measure things like record retrieval times. However, V-locity itself comes with very transparent reporting that will show you exactly how much storage I/O traffic it's able to eliminate from the disk storage layer. You can see what percentage of the reads and writes are being eliminated, and it will show you how much storage time is being saved by the storage not having to process all of that eliminated I/O. So if you're using thin provisioned storage, V-locity can also help you reclaim space. So if you're using, for example, thin provisioned VMDK files, it can automatically zero out free space so you don't have to wait for hours for an sdelete pass to complete. If you're thin provisioning down at the storage layer, it can also send SCSI unmap commands down to the storage controller to notify it of blocks that are no longer needed. And if your VMs are provisioned with dynamically allocated RAM instead of a fixed amount of RAM, such that the hypervisor can borrow some back to reallocate to some other VM, it's important for best results to make sure that you reserve enough RAM in your SQL VM's configuration for both SQL and V-locity. Otherwise, too much RAM in the VM will become driver locked by the hypervisor's ballooning driver, and that would basically mean that V-locity might not get enough RAM to cache with effectively. So it's certainly not going to compete with the ballooning driver or any other process that's running in the machine. Now, these are just some of the case studies that you can access on our website at condusiv.com, and you'll be pleased to hear I'm not going to give you death by PowerPoint by going through every single one of these. I'm an engineer, not a sales guy or a marketing chap. I'll just pick out one though, if I may. On the bottom left here, Bell Mobility. They're a telecoms company in Canada, and they saw the V-locity software reduce the storage I/O traffic to their SAN storage by 61%. That's a huge reduction. And this gave them SQL report queries that were 3 times faster with no additional hardware required. All they had to do was just simply install the software, which, as I mentioned earlier, is completely non-disruptive. There are no SQL code changes required, no reboots required, and 0 disruption to live running workloads. So, firstly, I hope this has been useful, and if it has, I would encourage you to share what you've learned in this session with your colleagues. See what they have to say about this. The simplest and in my opinion, best way to test V-locity is to try it for yourself with your real-world workloads. Don't take my word for any of this, try it. Everyone who's attending today will receive a full copy of the software from Dawn Rich Creek at Condusiv directly, worth about £375. Make sure you follow the best practice tips for best results and ensure that you leave at least 4 gig of available RAM to cache with. And by the way, you're very welcome to share the dashboard report data with a Condusiv engineer like myself and get additional analysis and get a written engineer's report. That's a completely free service and no obligation. The emails on the page will get you directly connected with a lead engineer for each region. So if you're in North America, use the first email address here, SRSE1 West. And if you want to come through to me directly in EMEA, then use the second email address, SRSE EMEA. Yeah, even if you have any questions after the presentation, please, you're more than welcome to reach out and get in touch. So just to finish up, if your organization would benefit from faster storage at a reasonable price, using the storage hardware that you already own in order to really boost the performance of the databases and other applications that you're running, I'd urge you just give it a try. As I've mentioned before, you're not going to disrupt any live running workloads. You don't have to make any SQL code changes, and the whole download and install will really take no more than just a couple of minutes. So use the software to not only identify those servers that will cause storage I/O issues, but fix those issues at the same time. So I hope that's been interesting. Let me see if I can bring up the Q&A box here. We'll see if we've got any questions. Okay, good. So I think all the only question was about the sound issue. So Frederick, don't worry, we will be sending you a copy of this session. And Shanila says we will install and have a try. Well, that's great to hear. Brilliant. Please do. You're not going to disrupt anything, as I say. And really, I don't want you to take my word for any of this. Try it for yourself and put it onto as many machines as you can, not just the database machines, but any machines that are sharing that same shared storage. That's where you're going to get the best result. So, Satya says, share the free download link, please. Yes, certainly. Let me do that. So if you go to, let's open up a browser here. If you go to condusiv.com/try, and I'll make that a bit bigger. Let's let that load up. Always seems to be a bit slower when I'm streaming this stuff live. But yeah, basically, if you go to a browser, condusiv.com/try, that'll take you to a page where there's a little registration form. You can fill that out, and then here it is. And then within a couple of minutes, you'll have that download link and can try the software. As I say, the evaluation version is slightly different from the full free copy that everyone's going to receive. The full free copy is just that. It's yours to keep. It will never expire. That's our gift to you, basically, to say thank you for joining me here. The 30-day trialware is trialware that will run for, you guessed it, 30 days. But that is intended so that you can put it onto as many machines as you want to. And what I would suggest is get it onto as many machines as you can, let it run for a week or 2 weeks, and then check those dashboard reports and see just which of those workloads that you're running are going to see the most benefit. And then you can make a decision as to whether that's something that you want to buy licenses for. Is that additional performance gain something that's useful and helpful to your organization? So let's see, we've got another one from Dave. He says, thank you, looks great. Look forward to testing. We'll share with my manager. Perfect, Dave. I couldn't ask for more. And please remember that I'm here to help all of you. If you have any questions, if you have any trouble getting hold of the trialware, remember my email address, you can contact me directly on is this one here, srsemea@condusiv.com, or feel free to give me a call. So thank you very much, everybody, for listening to this. I really hope it's been helpful. And yeah, I've been Spencer Allingham, and I look forward to seeing you all again in the future. Take care.